4 commuter trains in Madrid. The attack killed 193 people and injured thousands more. Quickly after, police found a finger mark on a detonator bag left behind at the scene. They ran the print through their systems, and the FBI declared a 100% certain match to a lawyer in Oregon named Brandon Mayfield. There was a glaring problem with this match. Mayfield didn't even own a passport. He hadn't been out of the United States in over a decade. When an absolute certain match falls apart against a basic fact like a missing passport, it reveals a significant gap between how forensic science is presented in court and how it actually functions in the lab. To find out how widespread this problem was, the National Academy of Sciences published a 350-page investigative report in 2009. Their conclusion was a bombshell. The Academy stated that, with the exception of nuclear DNA analysis, no forensic method has been rigorously shown to consistently connect a piece of evidence to a specific individual. This exposes a massive friction point between the institutions of law and science. The scientific method is designed to discard old theories the moment better data comes along. The justice system, however, relies heavily on consistency. Courts prioritize precedent. If a judge allowed a subjective, flawed test into evidence 50 years ago, courts are highly likely to treat it as legally valid today. Take bloodstain pattern analysis. In 1971, a chemist named Herbert Leon McDonnell published a book outlining a trigonometry-based system he developed alone in his basement. Plotting these trajectories as perfectly straight lines gives a high origin point, assuming the victim was standing. But analysts failed to account for gravity and air drag. Adding those variables lowers the origin point significantly, proving the victim was sitting. You see the same lack of testing in bite mark analysis. The logic sounds straightforward. If dental records can identify a deceased person, then surely a perpetrator leaves a unique identifier on a victim. But a study from the University at Buffalo proved that skin is a terrible medium for transferring imprints. It is soft and distorts heavily under pressure. Out of 89 bite marks made in skin, none matched the original model teeth. 12 separate studies concluded that bite mark transfer to skin is unreliable. Yet, because of historical precedent, bite marks and blood spatter math are still permitted as evidence in courts worldwide. To see how deep this trust in subjective testing goes, we can trace the history of fingerprinting back to 1890s Calcutta. At the time, criminals were avoiding jail by paying stand-ins to serve their sentences, and police needed a way to identify individuals. Officers built a classification system based on physical skin patterns, sorting ink prints by structures like whorls and arches. Today, software still scans for these minutiae, where ridgelines split, but the computer doesn't make the match. A human makes the final call. This introduces context bias. If police give a fingerprint examiner a submission form stating the suspect has a violent criminal record, it psychologically influences the examiner's interpretation of those tiny ridges. The final identification rests on a human decision. These conclusions are vulnerable to conformity and psychological pressure, especially when examiners are told about the high stakes of a case. If fingerprints and bite marks are flawed, we naturally assume DNA is the objective answer. In the 1980s, you needed a dime-sized sample to get a result. Today, analysts sequence profiles from less than a pin-hair's worth of material. But this extreme sensitivity introduces a new danger: trace transfer. In 2012, paramedics treated a homeless man, picking up his touch DNA on their equipment. Later that night, those same paramedics responded to a murder scene, accidentally transferring his DNA onto the victim. He was hospitalized during the crime, but spent 5 months in jail before charges were dropped. Crime scene evidence is messy. When 4 or more people touch the same object, creating a DNA mixture, their clean individual profiles slide together into a chaotic, overlapping cluster. Analysts have to guess which peak belongs to which person. In a 2013 test involving a complex mixture like this, 69% of crime labs got the analysis wrong. As our forensic tools become more microscopically sensitive, they paradoxically introduce more noise into the equation. Instead of offering an objective truth, analyzing complex DNA mixtures moves forensic science back into the realm of subjective guesswork. These systemic errors have a devastating real-world cost. In cases involving microscopic hair analysis, 33 people were sentenced to death. By the time the errors were found, 9 of them had already been executed. When the FBI later re-examined these historical cases using DNA evidence, the results were appalling. In many instances, the expert examiners couldn't even tell the difference between a human hair and a dog hair. Forensic techniques still have value as investigative tools, but crime labs must be reformed. Experts suggest instituting blind testing, completely isolating examiners from police narratives, their demographic context, and the suspect's criminal history. For the justice system to truly protect the innocent, it must adopt the standards of the scientific method. That means admitting when old tests are wrong, discarding dangerous historical precedents, and demanding absolute proof before taking away a human life.